Dear fellow coders, welcome to One Little Coder. This is day 5 of 8 days of Streamlit, where I teach you to build one Streamlit application every single day for straight 8 days. And we are in day 5, and today I decided to take a slightly different approach than what we have done in the past 4 days. So in the past 4 days, if you remember, we would start with a topic and I would immediately jump into the code and I would show you that what I've built, and then we would finally deploy and then the video would end. But today what I've tried to do is, or the approach that I'm trying to take is, instead of that part, I'm going to emphasize more on my thought process of how I arrive at that solution. So we're going to take a problem statement today, and I have the solution for the problem statement already on my Jupyter notebook. This is what mostly I do, where I create the prototype first on Jupyter notebook. Because I have to iterate a lot, I write the REPL structure of Jupyter notebook where I can run something and see the output. But that is not good enough, where we have to finally translate this code into a Streamlit application and then we have to display it. So this video is going to go through like this. First, I'm going to show you what is a problem statement. Second, I'm going to show you how are we going to design the UI, a little bit of wireframing. Then we're going to translate this code that we have on the Jupyter notebook, or in this particular case, a Visual Studio notebook, into a Streamlit App.py file. And then finally, we are going to deploy it if we still have enough time to do that. This is how the flow is going to be. If you do not want to wait and see how am I doing UI, what kind of tools that I'm using for wireframing, how am I copying and pasting code, that's completely fine. You can just skip this part. I would make sure that I'm timestamping that, so you can just finally see the part where I'm going to explain the code. So let's get started. Today's problem is something that I've been looking forward to do for quite some time, which is to create a chart to show the trend of Github stars. So there are a lot of solutions online that helps you see, like if you go online and then search for Github star tracking, you would see a lot of solutions that would help you, where you can just go there and then put a GitHub repository, and then it's going to help you with that. So for example, I've got a very I wouldn't say popular R package, but I've got an R package and I'm going to show the trend. So let's see how the cap R. I'm going to see the access, the star history, and then it's going to make a chart and it's going to show you. So this is how the star history looks. What we are going to do is we are going to build a very similar application on Streamlit. That's what we are going to do. And we are going to first start with the problem statement. The problem statement here is we're going to get the user input to know what their repository is, and based on that user input, we're going to show the trend of their GitHub repositories stars. Okay, so as simple as that. So the next thing that I'm going to do is I'm going to design the UI, and for that I'm not going to use any sophisticated tool. Like usually I used to use draw.io, but since we have got tl.draw, I've been using tl.draw for everything almost that I do. So I'm using this website called tl.draw.com to create that UI. So what do we want? First, we need a place, like let's say first of all we need a title. Okay, we need a title, and after we have a title should be title, right? Should be big. And after we have the title, we need a place where user can input the repo name. So either we can do a single repo name like this, or if we do not want to handle a lot of things, then we can do a repo name and a username, right? So we can do a user and then we can do a repo, so that we have like two components. Here you get the username and here you get the actual repo name, so that you don't have to do text cleaning and handle a lot of test cases. After we do this thing, let me reduce the size. After we do this, I think the next thing that we want is we want to show that there is a title, star history, okay, or star tracking, whatever we would like to call it. And then we are going to have like a chart that would ideally show the history, right? That's what we want, that would ideally show the history. Now if you take this chart itself is not your normal chart, because what you see here is a cumulative number, right? A cumulative number, because as the time goes on, the stars not just increase for a day, because you just build on the stars. So we are going to see the cumulative number. So that is one thing. And the next thing that I wanted to make sure is that while the user submits these details, now this is going to take a little bit of time. So I think we need to make sure that we have some sort of a progress bar or like a spinner that would indicate, that would tell the user that this is taking time. So while this process is happening, we want to make sure that the user is not left in the dark, but they can actually do this. And a few enhancements that we can do that right now we are not going to do in this video is, can we give ability to tweet this, or can we give an ability to share this? Can we give an ability to take a screenshot? So let's see what all of these we can do, and we can see if we manage to do any of those things. Okay, so like let's say these are the 3 features that we're talking about. Tweet this chart, share this with anybody, take a screenshot, and yeah, I think we are good. So the title should be ideally GitHub Stars Tracking. Okay. And I think, yeah, we're good to go. So we have like 2 text boxes. What is this? These are like 2 text boxes in Streamlit terms, text boxes, and we have like a chart. Most likely we'll use Plotly for this chart, to be specific, Plotly Express, because that's quite easy for me to draw. So Plotly Express, a line chart that shows the trend. We need a progress bar, and yeah, we get this user input, and behind the scene, if you want to know what is happening, so basically the way we are going to do is we're going to collect this, and if you see the GitHub API details, you would probably know that we are going to collect this, and once we have that, the code workflow is going to look like this. So first step is we need to have the API path, right? So API path, we need to build the URL for API, right? So that's the first thing that we need to do, and once we do that, let me zoom in a little bit. Yeah, we need the API path, and or you can call it endpoint, so whatever you would like to call it. After we do that, then we need to make a call. We need to make a call to do what? We need to make a call to do get the star history, right, with timestamp. That's the most important thing. So if you see the GitHub API documentation, you would see 2 cases. I think one is where you get the star details without the timestamp. The other one where you have to specify a custom media type, where you would get with a new value called star that gives you a timestamp that helps you track the history. So by default, when you make this call using without this media type, you would get a response without the star at value. But if you want the star at value, this is the alternative response with the creation timestamp when you use this particular header. So we need to make sure that. So star history. Now the challenge that you would get when you look at the API is, by default, the total number of pages that you get is 30, and maximum is 100. Okay, so this is what you get. Let's say that there is a GitHub repository that has got like, let's say 800 stars. Now, how would you get 800 stars? So this is a problem that's usually called as pagination. Okay, so now what is it called? It's called a pagination. Now there are multiple different ways to do pagination. I'm not saying this is the right way, but what I'm proposing here is, instead of doing this, let me slightly reduce the path. Yeah, instead of the way I want to do pagination is, let us say that we have a repository, like one of my repository has got 407 stars. Okay, now how would you do pagination? So there are the attributes that you have is, 1, you have per page. By default it is 30, but we can cap it till 100, and then you have a page value. What is a page number, right? So page number is like this. So what you can do is, ideally you can iterate through this and then get every 100 values in every page. But now how do you know where to stop this iteration? And for that, what we're going to do is, we're going to do a slight call separately to get the total star count. So it's called star gazers count in GitHub. So we're going to make a separate call first of all and get the star gazers count, and then we are going to use the star gazers count for our for loop, the range, and then we are going to use that value, and then we are going to make the for loop. So we are going to keep the star gazers count, and then we are going to use this value and divide it by 100 and get that value, and then loop it through this, and then finally we are going to have the JSON file. So at the end of this process, you have a JSON file, a response from HTTP, and then what you're going to do is, now we are going to convert this into a pandas data frame. I think pandas data frame is the best format for every data scientist, because we struggle usually with all the other formats. And then we have a pandas data frame, and then we are going to do a little bit of data manipulation, or I should even specifically say date manipulation, right? And after we do that, we are going to make a beautiful plotly chart. I don't know if the chart is going to look beautiful, but we are going to make a plotly express line chart, and that's it. So that line chart, we need to figure out how to embed it on our Streamlit front end. So this is basically, if you see our front end, that's quite small, and let me zoom in and then make it big. This is our front end, and this is our back end, and back end engine, whatever you would like to call back end. So let me give alternative colors just to make sure that you have the differentiation. So this is our front end and this is our back end. And to quickly summarize, what we are trying to build is, we are trying to build a GitHub Stars tracking, or a website that can give you GitHub Stars history, like how much your open source repos. One of the ways to share open source is GitHub, and you can see how much the stars have grown, like how much people have appreciated it. I mean, that's a very good habit, right? So if you like an open source project, the first thing that you should ideally do is, wherever they are, like you have to appreciate them, star them, give a shout out, those kind of stuff. So this is kind of a proxy for the growth of an open source project that a lot of people use. Not necessarily translate exactly into the growth, but yeah, it's a decent metric. So we're going to show it like this, and the backend is basically we are interacting with Github API, and then we are making some calls, getting stuff, and then finally showing the chart. The good thing is, this is a public API that does not require, this is a public API that does not require API key for a certain amount of calls. After the certain amount of calls, after you run out of that calls, like after you reach the API limit, then you might have to add authentication, but that should be fine. We are not handling that authentication part. We are going to deal with the public API that is free, that does not require any API key, and then we are going to use that. I would also link this GitHub documentation in the YouTube description. You should definitely check it out. It might give you a lot of information that I've not covered in this video. So this is our architecture. So like I hope this is useful, like how I go about it, how I think about it. And now what we're going to do is, I already have this backend kind of written on my Jupyter notebook where I have iterated, and I'm going to take you through the backend, and then we're going to build the front end. So now we are moving into the second part of this video. So let's look at the second part. Now when we go here, this is how the API. So as usual, I have not even saved the Jupyter notebook. It is still untitled one. So I'm importing the packages. I'm going to quickly go through it, because when I copy paste it, you would still know the different components. So right now I'm going to be slightly faster in the way I'm going to take you through these codes. So we are importing the package request for making HTTP calls and Streamlit. So for web app development, get the user and get the repo name. So because if you usually see the repo is like this. So let me see github.com/ coin market cap r. So if you see this repository, it is usually like this. So this is how the repo URL is. So that's why we are collecting it separately, so that we don't have to handle a lot of test cases. It's quite straightforward. So I'm hard coding these values now because I'm iterating on it. I have a repo like this, and we want to collect the star count URL, we want to collect the stargazers count. So I'm building the first API endpoint URL. So the first API endpoint URL looks like this, and I'm using the get request to get the response. And after we get the response, I'm converting into a JSON, or extracting the JSON and then extracting the field stargazers_count, and I'm just printing it, and it says I've got 407 stars. Woohoo, I've got 407 stars. I've got a repository with 407 stars. I don't know if it is a great thing or if it is nothing, but yeah, I can feel happy that this repository has helped a lot of people, that they've managed to even start the repository. So the next thing is, we want to define how much we have to loop, how many loops we have to do. So for that, I'm going to simply divide this by 100, because we're going to set page per number of results per page value into 100. Even though the default value is 30, we're going to make it 100, and we want to define how many loops we have to make. So it's a simple math. If you have 400 stars divided by 100, you get 4-ish something float value, convert that to an integer, and then add 1. So basically you want to do 5 loops so that you collect the final 7 value stars. So the loops value say 5, and now we are going to build the second part. So if you see our like backend has 2 parts. One is dealing with the pagination stuff. Now we have the loops value. Now we are going to go back and then build the main engine. So the main engine is now we need the star trends URL, and this is the endpoint for that. After we have that, we are going to create an empty list that looks like this, and this empty list is where we are going to append all the responses. So one thing that you need to note is the way GitHub gives you the responses is it gives you like this. So it gives you a complete detail, like you get the complete detail about, you know, like who's the person who starred, and there is one more column that says start at, right? So now what you need to do is you need to make sure that, you know, you collect all these things. So basically the way you count the star is you count all the elements. That is the way you count the stars, like count all the individual elements. So which means we have to have an empty list for every iteration, for every loop, for every pagination that we are going to do. We are going to append the response, extend the response to this particular list, so that finally we can use this to convert into a pandas data frame. So we have an empty list. The next thing is I'm just trying to see if my for loop writing skills are really good, because every time I get confused where the range is going to be. Is it going to count the final value? Is it not going to count the final value? So just to take that thing out of my mind, I'm going to say, okay, for page and range of loops, so loops have value 5. I'm going to add page.1. So why am I adding page.1? Because we are going to build the URL. So for the first page it should be 1, for the second page it should be 2, 3, 4, 5, so on, because Python is 0 index. So if you do not do this, it would start with 0 and you would not get any value there for the 0th page. So the API needs a page number 1. So that's why we are doing this. Next, we need to define the header. And what is the header? So this is the value that we got from this this documentation from GitHub. So let me quickly show you. Yeah. So if you add this media type, and then you know, you get this. So maybe additional information that I actually did not cover. Even before writing this code, before doing all these things, I actually went to a very nice website on internet. It's called Hoppscotch. I don't know if I still have it open. Do I have it open? Yeah, I don't have it open, but it's a very nice website called Hoppscotch, where I managed to put these things there. And I first verify. Maybe I can do it. Like, it doesn't take a lot of time. Hoppscotch. Hopefully, yeah. So this is a very good open source alternative for us to test API calls. So what I first did is I went here. I like, for example, if I go to GitHub, they would give me a CURL, right? I'm going to copy this and I'm going to come to Hoppscotch and I'm going to say import CURL, and I'm going to paste that here. Okay, and then I'm going to call it import. And after I do that, now Hoppscotch has already, you know, put the right things in the right order for me. So this is a GET request. I've got one header, and then, you know, I can just send the call. Okay, so now right now we are sending it without the media type. So I'll send it and I'll see, okay, is there a star at value? No, it's not. So now I'll go back to the GitHub documentation. This is what I actually did. Copy this, come back to Hoppscotch, and then in the header I'm going to replace this. And then now send it again. Now you see that there is a star underscore at value. So we have successfully managed to make the right one. Now you might think that, am I going to code everything from scratch in Python? No, that is the good thing about using solutions like this. And in fact, Hoppscotch being free and on web, making it easier. So I just click this button and I'm going to say show code. So if I'm going to run this directly on my shell CURL, I can get that. But let's say if I want to do JavaScript, I have the value. So if I want to do R with HTTR, I have the value. But because we are doing Python, I'm going to go to Python and say I'm going to use the request library, and I have the code here. That's it. I have the base code that I can simply use, and I just copy this code and then paste it on my VS Code, and I start building on top of it, like remove the hard-coded value, add parameters to it, add query to it. So all these things. This is what happened even before the VS Code that you currently see. So the headers are available now. This is how I validated that. And the next thing is we need to build the endpoint. So for me to validate that endpoint, so I made a lot of mistakes when I created this URL. So I have a separate separate value where I just built this endpoint, copied it, pasted it there, made sure that it shows result. So this is the base URL, and these are like additional query parameters. So we have two query parameters. One says per page value. So this is not dynamic, so I'm hard coding it. Second one, the number of pages which we are going to use while we are going to iterate, the page number 1, 2, 3, 4, 5. So that is something that I've got here. The next one is I've got the loop, where for every page in the loop range I'm going to make a call, and this page value is dynamic. As you can see, this page value is dynamic, and I'm directly taking the JSON and then adding it to response, and I'm extending this response to the empty list that we created. So at the end of this process, we have the empty list completely filled with all the loops, I should say the result of all the loops, and then this is added here. And yeah, so now the main part is done until JSON is done. Next, what we're going to do is we're going to use pandas JSON normalize to just convert that JSON into our data frame, and then we are going to use a little bit of a data manipulation. So what are we going to do? JSON normalize, take all the JSON, convert into a data frame. I'm just checking the data frame shape just to make sure that the number of stars that we got here, number of stars that we got here, which says 407. Where am I? Yep, 407 is actually equal to the number of rows that we have got. So that, you know, like I'm just basically checking data sanity. I'm not writing any test cases here, but you know, that is something that I would want to do if I'm actually productionizing this and making it a SaaS for others to use. But right now I'm just manually, visually checking it with my naked eyes just to make sure that 407 is equal. Okay, now after I've made sure that the values are same, that the star value is same, now I'm going to convert the start value, which is actually a timestamp, as a string. I'm making it to a date time value, and then I'm extracting date from that. Now that we have everything, so at this point you can actually see how the repository looks. Let me give a head of it. Sorry, did I say repository? Data frame looks. Now this is how it looks. So you have like start@, you have the user, you have the user ID, blah blah blah, their DP and all those things, and then you have all this information. Right now we don't care about any of this information. I don't care about any of this information. I don't want to know who are they. I don't want to know any of this. The two values that I'm interested in is start date, right? And then I want to know the number of instances, number of rows, number of observations for that particular start date. And if the simplest way to do that is take a group by of the start date and take a count of it, count of any value. So I'm taking a count of start date itself. So I'm grouping it by start date, taking a count of start date, and then I'm doing a cumulative sum. Now you might ask me why cumulative sum. If you do not do cumulative sum, your chart is going to look like this. Your chart will look like this. It will look like this. It will look like this. Why? Because one day you might have got 4 stars, one day you might have got 5 stars, one day you might have got 2 stars, one day you might have 3 stars. So your chart is going to, what we want is we want our chart to look like this. So at the end of this value, so it has 407 for this particular repository case. So that I know how did we arrive at 407, how did we reach that end position where we are currently, like how, like for example, let's say I might have kicked off a marketing activity here for my open source. I might have written a blog post, somebody must have covered it on YouTube. So I want to see what was the growth there. So cumulative chart is what makes sense. So I'm actually doing the cumulative sum here, and then adding it as a new column called count. So at the end of this process, you would see a data frame like this that has got two values. One start date, which is the date. Second is the count, which is a cumulative sum. So I'm not doing it in 2 steps. I'm doing it in 1 step. So again, you have a lot of different ways to write this. I've just written it as a straight line. Now, finally, now that we have everything ready, the data frame we have ready, I'm going to import Plotly Express as px. Just again checking whether everything is fine. I'm using px.line. And then giving the data frame name, the x value, y value, and we have the chart. You can see at the end of it for December, at the end of the December, yeah, somewhere we have 406. So it should ideally end at 407. Yeah, December 14, 407. That was the latest star count that we had. So yes, that's it. That's a project. I hope this code session, so yeah, we can do this st.line chat with Streamlit. So if you want to do it with Altair, but we're not doing I'm going to do it with Plotly Express. So this is basically now the code that I've prototyped, iterated. Now what I'm going to do is I'm going to convert this particular code into a Streamlit application. So until now there is no Streamlit, right? We have not done anything in Streamlit. Now we are going to convert this into a Streamlit application. This is going to be a live coding, so it is possible that I might make mistakes. So please don't get frustrated that I'm making mistakes, because I make mistakes every day. You just don't see that, but today you might actually see. So I've got a new project folder, so I'm calling it Github Star Growth. I've got two files. One is App.py, the second one is requirements.txt. In requirements.txt, I want to specify that we need requests to do HTTP calls. We need pandas, and we need Plotly Express. Plotly Express. I don't know if we can install Plotly Express separately, but yeah, just let's define it now. So these are the 4 libraries we want, and we want to import all of them as well. So let me even save it first and then go back here. I've got an app.py file, so import Streamlit as st, and import pandas as pd, and from pandas import json normalize, and finally import plotly.express as px. We have done all the imports now. So the next thing we need to make sure is we need to collect the data. So what I would probably prefer is would try to do all these things inside a function. So define a function. What is a function? I want a function that that makes create stargazers count, and it takes 2 values. Let's say I'm going to, so I can either take the value and then do it, or I can leave it, but right now I'm going to say user and repo. Okay, and inside that I'm going to define everything and paste. So for that I'm going to make this half and then this the other half, so that we can actually simply copy and paste it here, so that we don't have to just struggle a lot. So first we have user and repo defined here. The next thing is we need the star count URL, right? We need the star count URL. So let's add some doc string that says this function creates the stargazers count data frame. So at the end of this process, we are going to finally have the data frame which we are going to use to make chart. So this is what this function is going to give. Okay, so uppercase, lowercase, so make sure that you use the same value. Yes. So first part is done. Next we are going to make a request, and we are going to get this total star. Again, because this is like a code that's going to be deployed, we don't have to print this. It doesn't make sense. We're going to get the loops. After we have the loops, now at this point we have the loop. So until loop, the first part is done. If you want to keep this into 3 separate functions, it's completely fine. Now I'm going to build the second URL. Once again, just make sure that the values are same. We have called at the top, and the next thing is empty list. And next is we don't need this pagination. This is just for an example. We need headers specified. Why am I going there? Yeah. And we need to we don't need to check the URL. So what we need to do is we need to write the for loop, and the for loop is going to look like this. So make sure indentations are correct. You know about Python, right? If you miss one indentation, you're doomed. So we didn't import request library. How dumb of me. Import request. You can see, like, I noticed it with this error message or warning that we have got import request, right? So after we do that is gone. So when you don't have request, you can see it shows like this. So it's just an indicator for us to see before even we run the code that everything is gone correct. So at the end of this, we have the start response, and then we have already imported this. We're going to normalize this. Now this has to be written outside the for loop. Just make sure that you're writing it outside the for loop. We don't want to do the shape and check. Again, if you want to assert, like if you want to make a test case to say if the first response and the total stars are same, like the total count, you can of course do it, but I'm not doing that here. So next is I'm doing the date manipulation that I just talked about, changing the timestamp, extracting date from it. And finally we are going to have this. And still we are not done, because we need the repository that's called star trend df, and then this is exactly what we want. So what we are going to do is we are going to return star trend df. Okay, I've written it like written it quite bad. So now this is all done. Okay, so now our function is ready. I could have given some lines and spaces, but that's fine. So our function is ready now. So now what we need is values for this. So how are we going to get these values? User and repo. So we're going to ask the user. So first we need user is equal to st.text input, and then what is the label? We're going to say enter your repos, username, GitHub username, enter the GitHub username, not necessarily yours, right? You could be looking for somebody else's. So I can give an example. So value is equal to, I can give an example. So I'm giving mine. And then the next thing I'm going to do the same thing for repo. Repo is equal to enter the GitHub repo name. So we can say without the username. And I can just say coin market cap R. So we can even display the URL. So we can say st.write we can say your repo you are going to see the star trends for this repo. Okay, and we can say we can say something like this: user dot slash plus repo, and you can even end with slash if you want. So this is what we're going to do. So we can just say that. One thing we forgot is we have not even defined our title. So we're going to start with title, st.title star GitHub star tracking, and if you want to add a little bit of GitHub's logo, so search for the image GitHub logo png and images. Then you can get this images. I don't know if we have to specifically say transparent. Yeah, let's do that. That's better. So you can, like, which one looks better? So this, how does it look? So it looks quite big. So let me pick something that is smaller. I mean, like, we can of course change it on our end, but if you can get this, that's fine, right? So copy image address, come back to our code, and then say st.image, and then give that particular image here. Yes, that image is done. Why are we getting this image? Maybe I should open this image in a new tab, copy this. Okay, so this is how it looks. That's fine then. So we have it, and then we can add a subtitle. We can say st.subheader using GitHub star tracking with trend star history chart with interactive star. Let's put a star there. Where is the star history chart? Okay, so maybe we can add something here, star. Okay, I think the title is set. Input is done. So if you go back to our UI, so this is done, and now the next thing we need to do is we need to get the user input. So after we have these things, we need to now call this function. So create star gazers count will finally give us a repository, right? So I'm just going to, a data frame. So I'm going to call it df, and I'm going to say user comma repo. And we talked about giving a spinner or something. So we're going to say with st.spinner. We're going to say what is the message that you want to say. With st.spinner, we're going to say the message is downloading data from GitHub. Okay, and we can say please wait as well. Please wait. We can say stars are coming. Okay, so now we have this message. So this part is done. The next part is we need to make a chart. That we can put it there. So we need to make a chart. I'm going to call it simply a chart, and we're going to use plotly express line, plotly express dot line, and we're going to say data underscore frame is equal to df, x is equal to start underscore date, and y is equal to should be count. And we have this, so we can probably maybe give a title here, so markdown, and then we can say what is the title, so Github Stars Trend. Okay, that looks like a decent title. And we have the chart. Now we can use st.plotly chart and then embed this chart inside this. So at this point looks like we have got everything covered. So let's see, let's try to check our luck if it works. So I'm going to fire up my terminal and I'm going to say Streamlit run app.py, and then I'm going to wait for the URL. After we get this URL, I'm going to copy this URL. I'm going to go back to my browser, paste this URL. Oops, sorry, did I just copy the URL? Copy this URL, go back to my browser and paste it. We have managed to not make any error in the first attempt. So we have the repository. So it says enter the username. This looks very big. So what we can do is we can change the size of it. So what I can do is I can say the width should be smaller. So I can say width is equal to 200. Let's see, rerun. Yeah, 200 looks better. So we have the GitHub star tracking with interactive star history, and yeah, so instead of putting my repository, I can go and look for a repository. So TensorFlow recently released something called TensorFlow similarity. So I'm going to go and say TensorFlow similarity. Okay, there is an exception that we need to handle here. So it looks like, so let's see, downloading data from GitHub, stars are coming. Let's see if it works out. Yes, absolutely. So you can see it has got around like 600-ish stars. Let's see, where is it? Yes, it has got 688 stars, including mine. So looks good. Our code looks good. Our code looks fine, and it works. So like you can download the PNG. Whereas, yeah, you can download this as a PNG. So one of the things that we wanted to do is to offer those three features: tweet, share, and take a screenshot. So we have managed to successfully give that download the PNG at least. So this works fine. So there are a lot of improvements that you can do. So for example, instead of making it, reactive like this, you can get the input and then let the user, press the button. And when you do not have anything here, it would show an error. Like for example, if it is like this, it would, like when you are changing that, it would show an error. So you can do all those handling, but I'm not going to do any of those things right now. Also, another thing that you can do is maybe you can collect it in 2 columns. Maybe that is one thing that I should do. So instead of having it in 2 rows, we can keep it in 2 columns. That would make it slightly more intuitive. So we can say, first we can say markdown, repo GitHub repo details, and then we can specify 2 columns. So first, second is equal to st.columns of 2, and yeah, st.columns 2, and then we can say with first, I'm going to add this, and then I'm going to say with second, I'm going to add this. So let's see when we rerun this. Yeah, this looks better, right? So you have this, and you have this thing there, and you have the stars. So we are good. So let's change the theme and see when we change the theme, how does it look when we make it light theme. Oh, it looks good. It still looks good, and yeah, we have a good app. So now what we can do is like multiple things we can do. We can deploy it on Hugging Face Spaces, deploy it on Streamlit Cloud. This is something that we have been doing for quite some time. So let's take some time to just deploy. You can create a GitHub repository, GitHub Star Tracking app, Python app, and let's deploy it on Streamlit Cloud. I got confused with the names. GitHub Star Tracking app with Streamlit. 8 days of Streamlit. So yeah, as I said before, so this is always a thing, right? So you expect things to fall in place, but sometimes you just have to deal with these things. So I'm going to add create a file, create new file. I already have this content requirements.txt commit. I'm going to add another file that says app.py. I have to copy from my GitHub, paste it here. Our files are ready. Now I'm going to jump straight into Streamlit Cloud, log into it. It's quite simple, so sign in. If you have already signed in, they have different tiers. You can check it out. We have deployed apps in the past, so we have to copy the URL and go here. It's loading. New app. Paste the repository. We don't need to paste the entire repository. Yeah, this is fine. Main, and look for app.py. Deploy it, and now it's going to take some time to deploy it. I just want to make sure that the dependencies are fine. That's why, when it didn't happen in the first service, we're trying in the new service, so that I can be very sure that when this is deployed, it'll be like 100% fine. So let's wait for a couple of minutes and see if this gets deployed. The code would be in the GitHub repository. The code that we coded during this video would be in the YouTube description. And this app, if it is successfully deployed, the link would be in the YouTube description. Please make sure you check out the description. And also, if you create any application during this 8 days of Streamlit, please use the hashtag 8 days of Streamlit and then share it with me. I would love to see what you are building. Also, let me know in the comment section if this stuff is useful, or I'm just crazy making videos which doesn't help anybody. So I'd love to know. As you can see, our app is successfully deployed, and it looks fine. So it's running, and yeah, so yeah, we have 407. So this works fine. It's good, and yeah, so looks exciting to me. Try out with your repository. Please let me know in the comment section if it works fine, and also if you build something, let me know. Otherwise, I hope this video was helpful to you. This format, let me know about this format. And I honestly think that this video has added more value to your coding skills than what was before. And stay safe, take care of your family, and happy coding.